One of the most important things in designing a marine park or any natural resource management system is to make sure that we're working with the people who use these marine parks the most. One of the key aspects of a marine park network is that there are areas where we don't want fishers to go into, and we've got other areas where they are allowed to fish. So the challenge with pelagic longlining, of course, is that unlike other fishing methods where the net's attached to the boat and there's a high level of control, the line is set adrift from the boat, meaning that there's a higher chance it could end up crossing marine park boundaries into places where that sort of fishing's not allowed.
We're currently relying on current charts and our understanding of what the ocean's doing to, I guess the word is guesstimate where our gear is going to end up. Now, that's okay if it's out in the open ocean, but when we're trying to operate near marine park boundaries, that's where the problems begin for us. When I first saw the software, I just knew straight away that it was the solution. At the heart of the longline drift systems that we're testing at the moment, you have GPS beacons which are attached to the long lines, and what they do is they talk to the boat and actually show their position in near to real time as you can possibly get.
In the old days, before we had the GPS beacons, it was your initial shot was your trouble shot. You err on the side of caution, so you want to be 20 or 30 miles away from that reef because you don't know which way your gear's going to drift. Now that we've got the GPS beacons and we can see the currents on our screen, we can go straight to our shots, so we're not wasting time and fuel and bait. It's completely changed the industry now.
The feedback to date has been excellent. What we are finding now is that there's extra information that we really didn't conceive at the beginning of this project that is actually going to be of more benefit of fishermen into the future.
I get everything. I get sea surface height anomalies, I get currents, I get salinity, I get everything at my fingertips. So I've got 14 beacons. I know right along my 50 nautical miles of line where the temperature breaks are. It's coming up on the screen. Coming home, it shows me the currents. So I can see where there's an eddy running down to the south. I'll jump in that eddy. I'll save myself a bundle of fuel and a lot of time.
If fishers can understand how their gear is moving, they can actually catch a lot more fish while also keeping their lines out of protected marine environments. So early results are encouraging, and they suggest that there are benefits in this method helping to reduce bycatch, as well as helping fishers to catch more fish with less bycatch and less impact on marine parks.
On each trip there's many variables to what the ocean is doing, and they need to switch and adapt and change according to what they're seeing. The technology that's now available is actually helping them to do some of that thinking, and I think that's something that's going to benefit them into the future.
We've got a social responsibility. It's that simple. You know, we're guardians of this fishery for future generations.
Working together, we're seeing a lot of dramatic improvements in technique to reduce the impact of longlining on our oceans. And we welcome that innovation, and we look forward to continuing to work with the industry to advance it.